Cliff.
So, thanks for inviting me. I always feel a kinship to the UK. That's where my ancestors came from. So, anyway, this is what I'll talk about: evolution of diagnostic guidelines for Alzheimer's disease, what's going on in someone's brain. Now, what does this have to do with diagnostic guidelines? So, I mentioned that many research groups around the world started to incorporate biomarkers, multimodality biomarkers, into their research programs, and it became obvious pretty quickly that they had diagnostic value. And so there were two different groups then that incorporated biomarkers. There were a number of controversies, but the biggest one was around this, and that is, what is the definition of Alzheimer's disease? How should the term be used? So this is my last slide. The conclusion is that Alzheimer's disease is a continuum, and the disease begins with the appearance of brain pathology in people who are asymptomatic, and it ends with symptomatic people who have the full biomarker profile, A+, T+, and N+, to be updated to 1, incorporate plasma biomarkers, and 2, improve clinical applicability, because the system really has to work in what almost everyone in the field now believes is the era of disease-modifying treatments. So, and in fact, may not be a secret any longer at this point, but a group has been convened and is in the process by the NIA-AA, and is in the process of updating this framework. And in fact, there will be a session at the AAIC this July, Sunday afternoon.
So I've always had this strong conviction that obviously if we can see the microstructure, and that relates to your point about sensitivity of the actual assessment method, but if we can detect a change at that level, then we should gain traction on the question much earlier in the process. And so I think we certainly take the view, because we do have a diffusion-based approach. It's not noddy, but we have our own approach, which is sort of similarly, we would say, kind of separates the curves, as it were, and gains access to microstructural change somewhat earlier in the process, which I think is powerful.
So, yeah, I mean, both the points that you raise, one, I agree with everything you said. 2, we've tried to incorporate it into these models, but I mean, the point you're making about much greater sensitivity of neuropathology than anything that has been or realistically ever will be available in vivo. That's what we've tried to indicate with this detection threshold. The reality is that this detection threshold, I mean, it might be up here, but it's just hard to draw all this stuff on here. But the reality is, as you have correctly pointed out, there's so much sensitive structural and molecular change that the neuropathologist can see, that in vivo biomarkers can't see and realistically will never see.